All right, it's time to start Chapter 8 here, but how about a little bit of bell work first, a little recap. Do you guys remember how to solve these proportions? If you said something like along the lines of cross multiplication, you are absolutely correct. Let's see here. One thing that I like to do first, if I'm honest, sometimes I like to simplify fractions. This could be 1/2. So now I'm cross multiplying with smaller numbers. 3 times 2 is 6. Equals 1 times x is just x, and boom, I'm done. If you didn't notice that, it's okay. You could still multiply. You'll just have to divide by 7 in the end, and you'll still get 6. All right, the next one, I've got x squared is equal to 2 times 18, which is 36. So in order to solve for x, I've got to square root both, and I get x equals 6. It could also equal, or -6. In our class, we're mainly going to focus on those positive values, but -6 could still work, absolutely. They would just both be negative fractions in that case, right? So if you guessed that we're going to be talking about ratios and proportions, you are absolutely correct. That is how we're going to start out 8.1. So a couple basics about your ratios. It's a quotient of two numbers, right? Something over something, but it can be written in 3 different ways. You can have 1 over 2. You can have 1 to 2, like with a colon, or you could have 1 to 2. All right? They can and should be reduced. So if it's possible to reduce them, please reduce them. So an equation stating that two ratios are equal is our proportion. Okay? And it has means and extremes. The means are these two. The extremes are these two. They're the two outside numbers. They're the most extreme, extremely low and extremely high. The means are in the middle. Oh, wonderful. That actually kind of makes sense. And getting a little more mathy with you, the product of the means is equal to the product of the extremes. So we're just using proper math lingo. The product of our means and extremes, those are my extremes. These are my means. Well, 4 times 10 is 40, and 5 times 8 is 40. They do equal each other. Woo! So this next problem here, find the fourth proportional for each of the 3 terms. When they say the fourth proportional, all we're talking about is if you set up a proportion, you've got 2 over 3 is equal to 8 over what? I do not know. Well, how about I cross multiply and find out? So we got 2x is equal to 24, so x equals 12. Boom. How about the next one? Find the fourth proportional. So we've got a over 3b is equal to 6 over x. Now if I solve that one, I'm going to have a times x, so ax is equal to 6 times 3b, so 18b. And if I divide by a and divide by a to get x by itself, that fourth proportional, I'm going to have 18b over a. Yay! Fourth proportional. Awesome. So we're going to find the ratio of x to y if we've got this mess down here. I like this problem. I'm putting a star on it. I don't know why. Okay, so we want to find the ratio of x to y. So eventually we want this equation, or this proportion, to look like some x to y is equal to something, right? Well, how about we start by cross multiplying? Okay, because we got to get it to look like this on one side at least. So we're going to manipulate this equation a little bit. Well, when I cross multiply, I'm going to have 7 times 2x minus y and 9 times x plus 4y. I'm going to distribute. That's what I'm going to do. So I got 14x minus 7y is equal to 9x plus 36y. I'm going to when I get the x's on one side, y's on the other. Okay. So I'm going to subtract 9y and get, 9x and get 5x. I'm going to add that 7y, and that'll get me what, 43? Y. So I want to get x over y, which would mean that I have to divide by y, not a 4, but a y. And I got to do that to this side as well, right? I got to do whatever I do to one side to the other. Balance that equation. Okay, well, that's going to give me 5x over y, so I do also want to divide by 5, which allows me to cancel that. The y's cancel, and I'm left with x over y is equal to 43 over 5. So just rearrange that equation. I love that question. It's lovely. It's a little bit of a thinker and a little weird because you don't really get like a full-on answer that it would be, a traditional answer sense. But good for your algebra skills. Indeed. Good day. All right, a little more vocab for you. A mean proportion, or a geometric mean, which would be x in this case, is a proportion in which the means are the same. So in this case, what number would work to make them both the same? Well, I'd have x times x, which would be x squared, equals 3 times 12, which is 36, kind of like what we had earlier on, I believe. So I know I'd get x is equal to 6 or to negative 6, and we're going to go with the positive version in this case, although negative 6 would work just both sides would be negative, and you can change both sides to positive if you want it. All right, so 6 would be my mean proportion, all right, or my geometric mean. So either one of those words could pop up on the test. You could say, hey, find the mean proportional, or if the mean proportion is this, find the fourth proportion, whatever. To find the geometric and arithmetic means between 3 and 27. Note which one is greater. And what is an arithmetic mean? Well, if a geometric mean is where we cross multiply, you could think of this as like a cross add, if you will. All right, so we're trying to find the geometric mean. So let's start with that. 3 over x is equal to x over 27. So I'm going to have x squared equals 81. When I cross multiply, I'm going to get x equals plus or minus 9. We'll go with the positive. Boom, that's my geometric. Now over here, let's do the arithmetic. So for this, an arithmetic mean is just a mean, the average. Well, what's 3 plus 27? That's 30. And how many things did I add together? 2. So 15 is my arithmetic mean. Totally different than a geometric mean. Okay? Well, what is my mean proportional between 4 and 12? Remember, mean proportional or mean proportion, geometric mean, those all mean the same thing. Mean. Yeah, we're saying mean a whole lot. Favorite movie? Mean Girls. Not really. It's not my favorite movie, but it is a great movie. All right, so I've got 4 over, I don't know, equals, I don't know, over 12. Cross multiplication. So what's 4 times 12? That's 48. Is equal to x squared. Got to square root both sides. Now when I factor tree this bad boy, because I got to reduce my radical if possible. 48 could break down to 16 and 3. What's the square root of 16? It's 4. Can I square root 3? No. Boom, it's reduced. Some people like to do prime factorization and get a whole bunch of 2's, and it just takes too long. I like to be, efficient, quick. Time is money. That ain't funny. America. Ooh, a little twist here, it seems. 6 is the geometric mean between 12 and what number? Well, I could set up my proportion here. So it's between 12 and what number? Well, 6 is the geometric mean, which would mean those would both go there. I'm going to pop the 12 here, just because I want it to look like a proper fraction rather than an improper fraction. I want to find out the other one. Either way you do it, you're going to get the same answer. Okay, so even if I switch the x and the 12, it still mathematically work out the same. So I can choose to reduce the 6 and the 12 over here if I notice that to be 1 over 2. And that will make my cross multiplication a little bit easier. 2 times x is 2x. 1 times 6 is 6, so x is equal to 3. If I would have cross multiplied out originally, I'd have 12x is equal to 36. Divide by 12, and I still end up with 3. It's the same thing. Just sometimes simplifying, simplifying fractions will usually help you. Just don't make a mistake simplifying. But yeah, working with smaller numbers that way. Woo woo. All right, so we're about to get real algebra-y with this bad boy here. And do a bit of an algebraic proof. Not a 2-column proof with all the reasons and blah, 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 but we're going to show that this proportion here is equal to this proportion here. A wonderful, wonderful exercise in remembering your properties of algebra and making sure that everything is legal in terms of math. We don't want to go to math jail now, do we? So I've got A over B is equal to C over D. Now let's take a look at our end game here. I somehow need to get a b up here and a d up here and show that it's equivalent. I can't just add b to one side and add d to the other side, because I don't know if b and d are the same thing, right? That's not, I can't just do that. However, I can add the same thing to each side. So on the left-hand side, I want b up in the numerator, right? Well, what's b divided by b? I'll ask you. Well, b divided by b is just 1, okay? So if I add b over b to that side, I'd also have to add 1 to the other side, or in this case, I'm thinking I'd rather do d over d. All right? Woo! You know what? Let me take it a step back for you. Let's just say I want to add 1 to each side. You'd say that was cool, right? Yeah, I mean, I can add 1 to both sides. That's totally fine. And what I'm getting at there mathematically is that I can, you know, anything over itself is 1. That's where I get the b over b and the d over d. That's totally legal, right? These are equivalent. D over d is 1. B over b is 1. Cool, awesome. Well, they have like denominators on the left, so I can get a plus b over b, and I've got c plus d over d. And what do I have there? Boom, done. I've done it. Yes, I've shown it. Okay, and I think that this step up here, where I added the 1s, is actually pretty important. I like adding the 1s there because it's easier to grasp. It's like, oh, if I add 1 to both sides, that's cool. Well, why did I do that? Because I wanted these two added into the equations. Okay? All right. That was lovely. So here's our little bit of H-dubs for practice and, of course, enjoyment.